to, what did I say to call it? Count spaces, takes a string as a parameter, and returns the number of spaces contained in that string. So it's going to return an int called count spaces, takes a string as a parameter. Now we need to go through, we're going to have a count, so we'll have an int count is equal to 0. This is going to be the number of spaces we find. We start off at 0 because we haven't found any spaces yet. We're going to go through every single character inside of our string. So for int I is equal to 0, I is less than s.length. So s.length is the number of characters that are in the string. I plus plus. Each time through, we'll ask a question. Is the current character I'm looking at equivalent to a space? So if s.char at I, that's the current character I'm looking at, if that guy is equal to a space. If that's true, count plus plus. So this loop goes through every character in my string s. Each time through it asks, is the current character I'm looking at equal to a space? If it is, increment count. When this for loop is done, I've looked at every single character inside of the string. I'll go ahead and return count. So that guy right there. Or something close to it. Let me take a quick glance. All right. So questions about this? And actually, I could do this too. This will help. I'll turn the front lights down a little bit. Should become sharper. A little easier to see. All right. And remember, I do drop the lowest quiz. You'll have a quiz at the beginning of every class. For several of you, that's good that I drop the lowest quiz. So probably suck less next time would be the punchline. So given that, are there any questions about this? We all need to make sure this should be easy for us to do. If you come through 535 and you understood 535, this material should not be difficult for us. If it's been a little bit of a time period since you were in 535 and things are a little rusty, well, you should have had quite a bit of practice on your homework assignment that's due today, but at the very least, now that you see the solution, hopefully things are coming back a little bit. All right, so any questions about this? Want me to go over anything with this? All right. So I would expect quizzes to be along these lines. This would, actually down the line, this would be a pretty short quiz. Typically, quizzes are going to be related to the homework assignment. But since our homework assignment was kind of getting into Android, I asked you what should have been relatively simple logic for you to work through. Couple things I'll point out here since you didn't ask. Could I have said that? The red underline probably indicates no. So the question would be, why not? What is this guy? What operator is this? It's the equivalence operator, double equal sign. Okay, equivalency operator. Specifically, it's the equivalence operator for primitive types, primitive type values. So primitive types are like, that's byte, short, int, long, char, float, double, booleans. Okay, those are the guys that the equivalence primitive type operator works on. What kind of animal is this? Cat, dog, or string? String. Usually when I ask questions, I want feedback, right? We're this nice small class. We're all friends, right? Are we friends? We're friends. We're friends. Yeah, we're friends. So, yeah, this guy's a string. We know it's a string because of the double quote things, right? So I just listed all of our primitive types, right? Byte, short, int, long, char, float, double, Boolean. String was not in there, right? So this double equal sign will not work for comparing strings. All right. So this is the string representation of a space. We want the char representation of a space. Now, while I'm on that, I don't know, that punchline there, because I just advertised that the equivalence operator cannot be used for strings, let me review something that I cover in my 535 classes typically. But if you had a class with somebody else, you maybe didn't see this, but just for completeness, since we use strings a lot, I'll take a few minutes here and let's talk about it. Because when I say that this is the equivalence operator, it only works on primitive types, that's a true statement. But I actually omitted one primitive type because Java doesn't actually have a syntax for it. And I'll show you just by an example here. So if I say string s is equal to hello, and I say string s2 is equal to hello, and then I say system.out.println s equal s2, notice that Java's not complaining. Again, this is the double equal sign, right? For primitive types. What kind of animal is S? Cat, dog, or string? String. What kind of animal is S2? String. Oh, I didn't have to give you the options in that one. See, we're learning. We're better. So these are two strings. Yet Eclipse seems to be perfectly happy me using the double equal sign for those guys. Even though we just saw down here that it wasn't happy. Because the left-hand side down here was a char. The right-hand side down here, as I had it written before, was a string. Can't compare chars to strings using the double equal sign. But up here, I'm comparing a string to a string using the double equal sign. But I've advertised that this guy is for the primitive types. Now, Java does not think this is a syntax error, and it's not. This is not a syntax error, it's a logic error. All right, well, I'm going to show you this too by example, but first I'm going to trick you. Remember that from the last class you had with me? I always tell you I'm going to trick you first, and then I trick you, and then I laugh. Right? Remember that? So, all right, so what would you expect this is going to print out? So S is equal to the string hello. S2 is equal to the string hello. Hello, is hello equivalent to hello? This is asking a question. Is this value equivalent to this value? You think true? Okay, because hello equals hello. All right, so you're right, but for the wrong reason. Does print out true, but it's for the wrong reason. I'm going to show that to you here. I'm going to create a string S3. This guy will also be equal to hello. Okay? But I actually built this string using the constructor for strings. Yeah. Yeah. So usually when you look at textbooks for Java, you know, they say, oh, this is how you define a string. And I'll even advertise early on in a beginning Java class that this syntax, I usually call it syntactic sugar. Okay, I say this guy is syntactic sugar for the more long and drawn out version of it that I just highlighted. So this is shorthand for something like this. Now that's mostly a true statement, but it's actually not entirely correct. All right, so getting back to your correct guess wrong reason thing, if I go and change this, because you said this is going to be true, and it was true. And you're right why it was true. If I change this to S3, based on our initial, feeling, which I wanted you to answer the way you answered. That's why I tricked you that way. So we talked about it before class. She knew the right answer. All right. So now we might expect this would also give us a true, because hello is the same thing as hello, but it's not. This will give us a false. And the reason for that is what this guy is actually comparing here is not the contents of the strings. It's comparing it's the primitive type equivalence operator. And there's one primitive type that we didn't say out loud because technically Java doesn't have a syntax for it. And that's the pointer primitive type for memory addresses. Now, the easiest way I can show this is just drawing a quick picture, and it should be pretty clear from a quick picture. So first, I'll just throw a slide up here that says pointer. So this is a primitive type capable of holding a memory address. Java does not have a syntax for these, but they do exist all over the place in Java. And that's actually one of the reasons why I typically don't use a textbook in my Java classes. It's quite common for textbooks to actually mislead the student by indicating that pointers don't exist in Java. And we can get rid of that idea real quick. So here let's just prove that real quick. I'll go ahead and say int array AR is equal to new int array 25 system.out.println AR. Does that look like crazy memory address to you? Yep, pointer. We didn't have to look very hard to find it in the language. Okay, all a pointer is a memory address. What's true about Java, though, is Java does not give us a special syntax for working with pointers. Okay? That is to say, if we were in a language like C or C++, an older language, if I wanted to, I'll write in here, you're going to see all sorts of red stuff because this isn't the same language. But for instance, in C, I can say int a is equal to 5. Then I can do something like system.out.println. And here, actually, this might, let's just roll with it. Ampersand a. What this would print out is the memory address where a lives. Now we know the way computers work is if I create a variable here named a, some place in memory has just been created to store my number 5. Right? We asked Java to do it for us. It did the magic. We didn't have to worry about it. But we kind of understand the way computers work is there's memory somewhere. And you want to put 5 there. We're going to say, we're going to label this guy A, and we're going to throw 5 up there. Fair enough. In a language like C and C++, we have a syntax using the ampersand that says, give me the address where A lives. So that would print out the address. Similarly, I can say int pointer B is equal to the address of A. So these two lines, you know what? Let's just have fun with this. Just so it's almost like watching a historical documentary. Let's just open up, we'll just write a C program real quick. Oh, good, I already have a starting point for this. All right, so here's a sample C program, but we're gonna go down here, we're gonna, so we'll create our int A is equal to 5. Then we'll say int pointer B is equal to the address of A. And then we're going to come down here and we're going to print some stuff. So I'll do a print, and what I'm going to do is I'm going to print A is %D. B is %P, and actually I'm going to write it this way first. So I'm going to print out the value of, I'll label them better. So this is the address of A that I'm going to print out first. This is the value of B. B holds a memory address. This is an int pointer. So this is a variable capable of holding the address of an integer. So what C and C++ has is a special syntax like that allows us specifically to hold memory addresses, specifically to hold pointers. Java removed that. We don't have that ability in Java. So when I print this out, the address of A and the value of B should be the same thing, right? Because A, the address of A should be whatever B is, which is equal to the address of A. Oh, it didn't like. Oh, I forgot to put the comma in there. All right, so here is the address of A, and here is the value of B. Same thing? All right, crazy looking memory addressy things. Similarly, if I print out A, and this guy is going to be a integer, and I print out star B, that is the value at the memory address that B points to. This should give me 5 both times. And here I'm going to put a \n here so it kicks it down to the next line. So this will print out the value of A, which is a 5, and this will print out star B, which is the value that lives at the memory address that B points to. All right, so this should also give me a 5. There's 5, 5. Make sense? So in an older language like C and C++, we have this extra syntax specifically for working with memory. We can say, give me the address of something, or we can say, give me the value at an address. We have that ampersand and that asterisk extra syntax. Java omits that. Therefore, in Java, we don't have a primitive type like this. This guy is an int. This guy is an int pointer. We would call what I have highlighted there a primitive type in C and C++. Since we can't write that in Java, we wouldn't call that one of Java's primitive types. Because Java doesn't have the ability to allow the programmer to directly manipulate memory. Even though we proved back here that memory definitely exists. AR is a pointer, right? We just weren't able to specifically create a syntax for accessing the memory or the value at that memory. We're reliant on Java saying this is how you should use this kind of thing. So with that in mind, if I'm going back and drawing this picture, getting back to this whole hello thing, I had string s is equal to hello. And then I had string s2 is equal to hello. And then I had string s3 is equal to new string hello. All right, so those are the 3 things that I did. Now, what Java has, they have a literal space. Let me go here. All right, so they have a literal space that they kind of set aside. And then they have regular mem space, let's just call it. All right, and we'll even change the color here for our literal space. All right, so what happens is we would call a value like hello here a literal value. This is no different than me saying int a is equal to 5. 5 is a literal value. It is the literal value 5. Just like the char a would be the literal a. Okay, these are things that we didn't just invent 5, correct? 5 is a number we all are familiar with. So is 7. So is the letter z. These are literals. These are values that are just part of our working language that we're dealing with. Well, here, now, there's no way Java could have known about all the strings we might ever write. Because we can just keep writing strings that say all sorts of stuff. We can bang on the keyboard a couple times. There's no way Java could have predicted that. So when Java notices that we're trying to create a string literal, it checks our literal space to see, have you already stored the equivalent string somewhere? So when we define s, it's going to look in our literal space and see that, oh, you have not defined s before. Or you have not defined a string that's literal as hello. So inside here, let's just call it memory location 100. It'll associate with hello. Okay? When it gets to S2 and it wants to define S2, it'll notice that in literal space, we already have a literal hello. So it will assign to S2 that same memory location that already exists, 100. So when I say something like S equal S2, it's actually saying, is memory address 100 equivalent to memory address 100? Make sense? Now with this S3 thing, because I'm using the new keyword, what's the new keyword? What does that guy do? Yeah, new memory location. It's our, I usually call it our real estate agent. So this guy's in charge of going and finding memory in the operating system. So the second I could do that, I'm basically saying, look, I don't want you to check the literal table. I want new memory. I'm not buying a used memory. I'm not buying used cars here. I want new memory. So it's not going to go and search literal space. It's just going to come in here, and it's going to say, okay, here's your new memory. We'll put it at 217, and we'll throw a hello there. I'm just coming up with memory addresses that I can write instead of coming up with a crazy hexadecimal value. So we just decided that at memory location 217, we went ahead and put your string hello. That is why, well, here we'll do it in a separate. S equal S2 boils down to true. And S equal S3 boils down to false. Because this guy up here is really asking the question, is 100 equal to 100? This guy down here is asking the question, is 100 equal to 217? Does that make sense? And that's actually a really important thing to understand with all of our modern languages, because this is how strings are compared. Is using this is how strings are stored. They're stored as literals, which means we're not going to create more memory than we need. If you're going to have the string hello stored 30 times, unless you explicitly use the new keyword, it's going to reuse that same memory location that it used to store hello all those other times. And that just makes sense. That's efficient, right? That's a memory efficiency type thing. Well, But it's important for us because wouldn't it be pretty easy for us to say, oh, well, the way I compare things is with the double equal sign. Therefore, if I want to compare one string to another string, I can compare it using the double equal sign. Now, the danger of this, though, is that sometimes you'll get false positives. Right off the bat, our very first example here, she answered right, but for the wrong reason. But she wouldn't have known anything was wrong, right? Like, oh, this is how this works. They must have changed it. This is how strings work in Java now. She got lucky. If you happen to be working with something that is only dealing with literals, maybe it would work for what you wanted to do. You know, if you never actually created new memory, you know, oh yeah, that's the same string that lives there. But most of the time, if we're comparing strings to each other, we probably care about the contents of the strings, right? So if we want this guy here to give us a true, right now it's giving us a false, we would actually compare these strings by saying s dot equals s3. This says use the string method. This is the instance method that lives in the string class to check to see if the calling string is equivalent to the string I passed it. Make sense? Now it's not looking at memory addresses. Now it's looking at contents. And it does, and in fact, hello and hello have the same contents. So now this would be true. So there's your true. Make sense? Pretty important concept to understand because it's one of those that you can get tricked into thinking you understand it pretty easily. All right, questions about any of that stuff? Yeah, I mean, because this is actually an int. So a char, I mean, s.char will return a char primitive type, and a char primitive type is an unsigned integer. So actually, this is a number. At the end of the day, it maps to something on the Unicode character set. So, but as humans, we think of this as a char. The type is a char. Just under the hood, it's stored as a number. But we're comparing whatever this character is. So single quote something single quote. We're trying to compare to some string literal. And it doesn't make sense to compare a char to a string. Doesn't make sense to compare a cat to a dog. You know, these are two separate things. Up here, it allowed us to try to do it because a string and a string are the same kind of animal. We can compare two dogs, or we can compare two cats. That make sense? Yeah, so if you really wanted to, I mean, if you just were just bent on using the double quotes there, you could say .char at 0 there or something like that, and that would work. So this is saying, give me the string containing a space and give me the character who lives at bucket 0 of that string, which is the char space. Nobody would write it that way, but you could. This would be an accurate way of representing it. All right, and actually this becomes kind of, I think, another important concept is there isn't just a right answer to these things. We can come up with the way of asking, is this guy equal to a space, several different ways. You know, how else could we do it? Could we go and look up, here's another way. Let's go and look up the Unicode characters. Unicode character for space. Okay, that looks like it's value 20 is the Unicode character space. It's going to be UTF. Well, let's just assume that's correct because we're not going to run it anyway. So what we would say here is we would ask, is the integer value of this char equivalent to 20. That's another way of asking, am I looking at a space? Even though to most people, you look at that and say, that makes no sense, right? Because this relies on us understanding how chars are implemented in Java. Chars are implemented as, well, here, we can actually test this here real quick. System.out.println. I actually have to build it funny. This is a space. Let's look at it that way. So I'm concatenating some strings. I'm going to write out the text. Is this a space? And actually, I'll put no space right after that. Then I'm going to try to concatenate onto that the character version of the Unicode value 20. And then I'll concatenate onto that a question mark. So we'll know that 20 is the Unicode value of space if what? If we see what? If we see a gap between this and our question mark. If the question mark is right up against the colon here, that means this guy must not have been a space. In fact, if it's something else, it'll probably be like a question mark or something like that. All right, yeah, so it was right up against it. So that guy was not a space. Unicode value for space. So it wants us to actually write this. It is 20, but it wants us to write it using the Unicode. Well, here. Just do it that way. We'll print out what the integer value of that is. 32 is the space. So there's our 32, there's the space. So with that in mind, we would actually write it. It's equal to 32 down there. So even though this looks like mathy crap, the reality is that we've discovered that 32 is the Unicode value for a space. So we're going to ask if the integer equivalent of the character we're looking at, that is the Unicode value for the character we're looking at, if that's equal to 32, that means we're looking at a space, therefore increment count. Make sense? So different ways we can solve the same problem. This one doesn't make a whole lot of logical sense. It relies on us understanding what's happening under the hood quite a bit, but it will still work. All right, other questions about this pointer stuff? Pointer is going to be pretty important for what we're going to talk about today. Okay, so then let's go back and let's look at our homework assignment. And I'll actually go through the process of checking it out, making changes, pushing the upload, so you can kind of see what I want you to do on your homework assignments. Because I mentioned in Slack that you should fork the GitHub repository so that you get your own copy in your account. Then check your copy out. Therefore, when you make changes and you push them back, you're allowed to push them back because you were making changes to your copy. If you check my copy out and make changes and then try to push them back, you don't have permission to write to my GitHub account. So it won't let you push back. So you have a couple of different ways you can accomplish it. You can do what I just said. So you fork it to make a copy of it in your account, check that out, work out of that, push it back up there. Or you could download it from my account, giving you a directory here on your computer. Open that directory, do your homework, whatever, and then share it onto GitHub. Ultimately, it'll then get up there in your account. That makes sense? Okay. So, but I think the first way is the way that most people who use source control like GitHub would probably do. So I'm actually going to, well, actually, am I going to be able to do that? I don't think I can make a fork of my own repository. So, well, that's okay. I can still do it. I'll just pretend like I'd already hit the fork button. Okay, so I'm one of you. So we went up here to GitHub. All right, here's that homework assignment that I put up last time. All right, so I wanted you to fork the repository. So notice here I have some other GitHub accounts. I don't want to fork it onto one of those. They're production stuff. But I would want each of you to go to my page here that I gave you the link for and click fork. And what that'll do is it will give you that repository in your account. So you would then see something, where are we at here? Something like this on your GitHub account. So if you clicked on it, you would see it in here, but you would own it. Okay, you would get a copy of all my code. This isn't working out of my account, it's now working out of your copy of it. Then I'd go up here and I would copy that URL. Okay. Now I'd come down here and I would go ahead, I'm gonna close this here. All right, so when you open up Android Studio, close all the extra windows so you are sitting at this window here. And then what I would do is I would say, check out project from version control. So click that, choose GitHub. Okay, it wants to know whatever your master password you set up on there was. So this is for your account. I thought I typed that right. No. Okay, now I'm going to paste in my GitHub URL up here. And you can test that and it'll make sure it works. So, test was successful. So it's telling me that this is a legitimate GitHub URL. Now it's asking me, where am I going to save this to? Right now, it's going to put it back in my Dropbox. But so for the moment, just for this example, I'm going to go ahead and I'm going to put this on my desktop. There we go. All right, so I'm going to check this out to the desktop. And the directory name is going to be the fall, homework 1, whatever. So I'm pretending to be you right now. Okay? Everybody follow me so far? So when I clone this, what this is going to do is it's going to download it, put it onto my desktop. This is going to be equivalent to what you do if you go there and you download the zip file. It ultimately is the same. But what I'm showing you here, this is how most people use source control. Because the idea is you check it out, you make your changes, whatever, you commit them, upload them, and then you can delete that local directory because your code's actually stored up in GitHub. That makes sense? So this is handy for people who maybe work on a public computer or something like that. But ultimately, this is just bringing the code from GitHub down locally. So I'll go ahead and clone it. Checked out from version control. Do I want to open it? I'll go ahead and say yes. Sometimes you get that message because it tries to load something before Gradle finishes building it. So just hit keep all and it'll eventually finish doing its thing. Okay, and here is my it's asking me if I want to add this XML file to my Git. In general, whenever it asks you if you want to add something to the Git, I would say yes. So I'm going to say, remember, don't ask this again, and hit yes, because that means that Android Studio created some other file in your project and it wants to make sure that you want it as part of your Git repository, we might have been able to say no there and it would have been no big deal, but these are just text files. They're not going to be too big. Okay, so now we have our project here just to kind of show you the process. I'll go into, here's app, source, I think it's this one, main, then this one, and here's main activity. So here's the code currently in there. And I'm just going to throw a comment somewhere in here. I'll put it in on create. We'll just throw a new line up here. And then I'll check it back in just so you see the process. Okay? So I'll go into my code here. And on create, I'll just do a little LOL comment. Now I'm done working for the day. Okay? The average American work day. So, then I'll just come up here. We'll go to VCS. This is the version control stuff. I'm going to go to commit changes. I'm done working for the day. I want to commit my changes. And I put a little message here, said hard work today, added one comment. With a smiley face. Okay. It'll go ahead. It'll already have check marks next to everything that has changed. So it'll show you the stuff that it thinks it's updating. So notice here that it sees that I've updated main activity.java. And then it also has an update to those XML files that it must have updated on its own. That wasn't anything I did, just let Android Studio do its thing. So then under commit here, you can do commit and push. That saves you some time because there's really two things that you're doing here. One is you're committing your changes to your local Git repository. And then ultimately we want to push the changes to GitHub. So if I do commit and push, it'll commit it here, push it there, all in one move. So I'll do git and push. Some files contain problems, no errors, one found. Would you like to review them? You know, it's just saying that it did its code analysis stuff. Do you care? I'm going to say, no, I don't care. I trust you did a good enough job. So I'll say commit. It's asking me for my GitHub username and password. You should only have to do this once. It's going to save it afterwards. All right, so this is the stuff it's pushing. Let's click push. 3 files committed, push successful. So now if I come back here to GitHub, I just hit refresh on this page. You see that on create is now different. Make sense? So that's the process. All right, so now if I wanted to, let's say I was on a public computer. If I wanted to, I could go ahead and delete that folder from my desktop and then walk away because I know all my changes are committed and stored in GitHub. And then tomorrow I can go to a completely different computer, use Android Studio, check it out, work on it for an hour, whatever it is, commit, push my changes. Now it's up there. I can delete whatever's here. Typically, you're working on the same computer or when you do your homework, so you're probably not going to delete the folder over and over and over again. But a good, so kind of just filling in some of the blanks here, if you're somebody who uses version control, which really plays into somebody working in like a team of developers, where you might not have been the last person to make changes to the code, you know, that type of scenario. A good rule of thumb is whenever you're done working, always push your changes, unless they're not anywhere near done. Okay, because the idea would be when you check stuff out and you're going to work on it, you don't want to push bad code up to the cloud. So that's why a lot of times they'll have like a beta branch in GitHub and then they'll have the production branch. So at the very least, you don't want to push bad code to the production branch. So sometimes a developer, so each developer might have their own branch of the code that they can work on. And then when they have whatever they were in the middle of working on kind of done, then they can push it to the beta branch, something that's supposed to be like ready to test, but not ready to release yet. But you run into the situation sometimes where let's say that you and I were both working on the same files and you finished yours yesterday. You pushed it up to beta. I've been working on my bugs over here and now I'm ready to push my changes. And it happens to be that I was working on the same file. Well, what you can do is you can do a merge. So GitHub will support, well, it's actually the Git protocol that supports this. It'll take your version of the file, my version of the file, and show me the differences. Now the hope is that I was working on one function, you were working on another function, and we're good. The bad thing is that we're both working on the same function, and we're deciding whose code to destroy. But the point is, it's made for those types of situations. But obviously, when you get more people involved, that's when things get more complex. But let's say you're working with somebody, or maybe you work on your code across multiple computers. Maybe you have a laptop you work on sometimes. You have a desktop at home you work on sometimes. If you always check if you always commit and push your changes at the end of the day, a good rule of thumb to do would be when you first sit down, you open it up, go into Git and do a pull. All right. So I'm doing a pull from here. And so that's my remote. I'll do a pull, and it pulled no items because my local copy is identical to the copy in the cloud. But a pull will say, well, bring your local copy up to date with whatever's in the cloud. That make sense? All right. We're at 6:02. Okay, so let's take a. I want to stop on the hours. I don't want to get too far into this. Let's take a 10-minute break. That way we can just solve the homework on the next stop. So come back at 6:13.